Hello students, this is AMOL INGOLE. In this video, I am going to explain state diagram for convolution encoder. The convolution encoders are finite state machines. Entire behavior of a convolutional encoder can be represented using state diagram. So the state diagram is one more way of representing a convolutional encoder. We have already discussed tree diagram. So this is the second way of representation of convolution encoder. At any time step, the encoder will be at any of the 2 raised to power m finite states, where m is nothing but the depth of memory. State of the encoder is represented by a circle or a box like this. So if the encoder is in the 0 state, you can show that state in the state diagram by a circle and the state written inside it, that is 0 0. Or you can also use a box to show the state and the state written here as 0 1, like this. Whenever input changes, there will be shifting of bits in the encoder, which also changes the state of the encoder. So this change in the state of the encoder can be shown with the help of lines with arrow pointing towards the next step. So you can use a darker line when the input is 0. You can use a darker line with arrow when the input is 0, and when the input is 1, you can use a dotted line with arrow pointing towards next state. The arrow should point towards next state, whether the input is 0 or 1. Initially, encoder will be in the 0 states, right? So you have to start drawing the state diagram considering the encoder in 0 0 state. State diagram can be drawn from the response table, or it can also be drawn from the tree diagram, which we have discussed in earlier video. So we have already discussed tree diagram, so you know well how a response table is prepared for the given numerical. At any input sequence, it can be encoded using state diagram. These are a few examples of state diagram. You can see here a box is used to show the state. Here a circle is used to show the state of the encoder. Here darker and the dotted lines are shown for input bit 0 and input bit 1. Whereas there is one more way of showing the input and output. You can use all dark lines by showing the input bit and the corresponding output bit by giving a slash. So one oblique the output. So this one indicates the input bit, and oblique, after oblique, whatever you see is the output of the encoder. Let us discuss this numerical. A feed-forward convolution encoder is given below. You to construct a straight diagram and encode the input stream 1010. So we are considering the same numerical which we discussed in the tree diagram. This is what you can easily identify from the statement of the numerical, that is n is equal to 2, k equal to 1, and number of memory stages m is equal to 2. And if you know how to draw this response table, how to prepare this response table, or you can also use the earlier video to understand how this table is drawn. So I'm considering that you know it very well how to draw the response table. Let's move ahead and see how a state diagram is drawn. So we are following this way of showing the 0 and 1 bit input, we're using darker line with arrow for showing the 0 input and dotted line with arrow for showing the input 1. You have to start with the 0 0 stage. The first thing I'll show is all the possible state of the encoder. So as we are discussing encoder having two memory units, so there will be 2 raised to power 2, that means 4 state of the encoder. So those 4 state I'm showing with circle. I'm using this way of showing the state of the encoder. So I have shown you can use any sequence to show the A, B, C, D or all possible state. Okay, let's now begin. So you have to start with the 0 0 state. When you are in 0 0 state and you are giving input 0. So I'm giving input 0, that means I have to use a darker line. Show the next state. The next state would be 0 0. That means you are in 0 0 state, giving input 0. The next state would be 0 0. So the same thing can be shown like this. As there is no change in the state, you can show the same state by showing a loop. And this is the output. This is the output 0 0. This is the output 0 0 of giving the input 0 and the initial state is 0 0. Okay. Now the second row of the response table is you are in 0 0 state and giving input 1. The next state would be 1 0. Next state would be 1 0. So here I'm going to use the dotted line. Why? Because I'm considering input 1. So show the next state as 1 0. So this is the next state 1 0. I'll be showing this with a dotted line along with the output. The output will be 1 1. Output will be 1 1 here. Okay. So the 0 0 state is over now. Let's now see 0 1 state or state B. So you are in now 0 1 state and giving input 0. The next state would be 0 0. That means from 0 1, when the input is 0, you will go to 0 0 state. The darker line is used because we are considering 0 as the input with output 1 1. So 1 1 is the output. This is the output 1 1. Okay. Now when you are in 0 1 state and input 1 is given, you will go to 1 0 state. So from 0 1, next state would be 1 0 if the input is 1. So the same thing can be shown with a dotted line along with the output here. Output will be 0 0, right? So two states have been completed. Let's now see the 1 0 state. 1 0, you are in 1 0 state and you're giving input 0. You are in 1 0 state giving input 0. The next state would be 0 1. I'm showing this with a darker line because 0 input is considered. The output will be 0 1. You can see this here. Output will be 0 1. When the input is 1 and state is 1 0, the next state would be 1 1. So next state would be 1 1, showing this with dotted line along with the output 1 0. You can see this here. 1 0 is the output. Next state is 1 1. From 1 0 to 1 1 along with output 1 0. Now the last state, which is 1 1. When you are in 1 1 state here and the input bit is given as 0, you will go to 0 1 state. Here is the 0 1 state. So show this with darker line along with the output 1 0. Along with the output 1 0. Same thing, input 1, state 1 1, and you will remain in the same state, right? So show this with a loop with the dotted line, right? Show this with a loop with dotted line along with the output 0 1. So this is how you can draw the state diagram. Once you have the state diagram ready, you can use this state diagram to encode the input bit stream of any length. To encode the input bit stream of any length. So we are considering now the input bit stream which was given in the numerical, and it was 1010. Let us encode this using state diagram. I'm considering the same state diagram which we have prepared. Let us encode the output. The first bit you have to start with, see, you have to start with 0 0 always. So I'm starting it with 0 0. Now I'm entering first input bit, that is 1. So when you input the first bit as 1, one input bit is used. That means you have to use a dotted line. So follow the dotted line because input bit is 1 and it will take you to the next state, that is 1 0. This we have already drawn. So why to use dotted line? Because the input bit, first input bit is 1. So for 1 we are using dotted line. For 0 input bit we are using darker lines from the state. So we were in the initial state 0 0 and then the input bit 1 was given and it took us to 1 0 state with output 1 1. So we'll be only writing the encoded output as 1 1 here. Okay, let us take the second bit. Second bit is 0. That means you have to follow darker line from the state. Okay, this state. From this state you have to follow now. So 0 is the input given. So you have to follow the darker line which leaves 1 0. So this is the darker line which is leaving 1 0 state and it will take us to 0 1 along with output 0 1. So 0 1 is the output. It's not the state. This is what you're supposed to write here, 0 1 as the output. Let us consider now the next state from 0 1 state. So next bit is 1. Next bit is 1. So this from this state you have to follow dotted line because input bit is 1. So following the dotted line leaving from this 0 1 state. Following a dotted line leaving from 0 1 state, that will take us to 1 0 again. Okay, and you have to take this 0 0 as output bit, 0 0 as output bit. Okay, again you are at 1 0 state, taking the last bit. Now it is 0 again, so you have to follow a darker line going out from 1 0. So the darker line going out from 1 0, that means the output the input bit is 0. Again you have to take this as output 0 1 here. This is how you can trace down any output. You can trace down any output from the state diagram. It need not be always a 4-bit. It can be of any length. Any length input bit stream can be encoded to get the output. Thank you.